Okay, today we're going to have a look at how many covalent bonds, different sorts of atoms uh, form, and that's going to be very useful in predicting formulae and predicting structures later on. Okay, so what I've drawn here is I've drawn the first period, the second period of the periodic table. Here we've got, okay, so going across our periodic table, we've got group carbon in group 4, nitrogen in group 5, oxygen 6, fluorine, neon, and so on. Other important elements that we could have there, then we would have we'd have silicon here, that's not very important. Phosphorus, which we'll come across later, yeah, put that there. Sulfur is also is in group 6, chlorine, very importantly, and argon. Okay, they don't form any covalent bonds, so we're not really interested in them. Let's put silicon there as well, even though we don't really do that much. Okay. And then we've got our halogens, we've got fluorine, chlorine, bromine, iodine. The other two are quite important. Okay. So let's see the number of covalent bonds. Now, if you look at our previous, the previous lesson, well, how many covalent bonds does carbon form? So let's put like number of bonds. Well, we had methane, CH4. Carbon always forms 4 bonds. We looked at so I just put CH4 there to remind us. We think, what did we have with nitrogen? Well, nitrogen formed NH3, didn't it? And so that means it's forming 3 bonds. Oxygen is, well, that was H2O. So that likes forming 2 bonds, hydrogen fluoride, HF. So that's 1 bond. And then if you want, for the sake of completeness, that's 0 bonds there. So we do get quite a nice pattern there. And that's, of course, because of they want to have 8 electrons in their outer shell. So carbon group 4 form 4, 3, 2, 1. Okay, now that's going to be very useful when we are trying to draw some structures. So let's have a little think about the bonding in oxygen in O2. Okay, I'm going to, I think I'll scroll up that. Okay, but there's our, don't forget our 5 steps for drawing for drawing a dot cross diagram. That's really important. That's up there if you need to refer to it. So let's look at oxygen, O2. Right, so if we're going to do it our normal way, what we'd say is, right, so first of all, oxygen is in group 6. So we draw the atoms with the overlaps. I don't like that oxygen, it's very irregular. Let's try and draw that again. That's slightly better. Right, so we draw the overlaps, then we draw a dot and a cross in the overlap. The next thing is to then say, have we drawn all of the electrons? Well, oxygen is in group 6, we've only drawn 1, so it needs 5 more. So 1, 2, 3, 4, and 5. And this one here is going to be 5, 1, 2, 3, 4, and 5. So the 5th step is to check each atom has a full outer shell, and that's where we've got a problem, because we can see each oxygen there thinks it's only got 7 electrons, so that's clearly not going to work. Now, of course, what really happens here is oxygen forms a double bond, doesn't it? So if I get rid of that electron there, and I'm going to put it in there instead, and get rid of that electron there, and put it there instead. Now, let's do step 5. Check each atom has a full outer shell. Well, it's got 2, 4, 6, 8. Yeah, that's fine, and the other one's fine as well. So that is the bonding in oxygen. Now, how do we know how to do that? Well, there's a good way. We said that if you looked further up here, we said that oxygen likes to form how many bonds? It likes to form 2. So before we started drawing our dot cross diagram, it would be a good idea to do something like this. Here's oxygen. Now, so if that's a single covalent bond between two oxygens, we know there's something going wrong there, because oxygen likes to form how many bonds? It likes to form two. Each oxygen there is only forming one, so that's not going to work. So what we realize then, if we know that oxygen forms two bonds, is that must be a double bond. Each oxygen is now forming two, so that's good. And then when we were drawing the dot cross diagram, what we would have done is we would have realized that's a double bond. We've drawn, so step one would be normal, yeah? We'd say, okay, this is a double bond, so we don't just put a pair of electrons in there, we put two pairs of electrons, so dot and a dot and a cross. Then we'd say how many electrons, well, we accounted for all of them. Now each oxygen has got 6, we've only drawn 2, so I need to draw 4 more, sorry. And the same for that one. And then you'd be able to see, yeah, that's the correct dot cross diagram for oxygen. So it is very useful to know how many covalent bonds each element forms, and it's very easy to do that from its position in its periodic table. So bearing that in mind, let's now see what happens with the nitrogen molecule N2. Okay, so let's get rid of that. Okay. So nitrogen is N2. Nitrogen is in group 5. So before we do our 5 steps things here, let's think nitrogen. Well, it likes to form how many bonds? It likes to form 3. Okay. So if I did this, that would clearly not work because each nitrogen is only forming 1. So what can we do? Well, make it a double. Still not good enough, is it? Of course, you can turn that into a triple bond. By the way, triple bond is the highest you can have. You can't have a quadruple bond ever. So the nitrogen forms a triple bond. Each nitrogen thinks it's forming 3 bonds there. So let's draw the dot cross diagram for that. So step 1, do where the overlap is. Step 2, put the electrons in the overlap. Now it's not just a pair of electrons, it's 3 pairs. So we want dot, cross, dot, cross, dot, cross in there. Nitrogen is in group 5. How many electrons have I drawn for each nitrogen? I've only drawn 3, so I need to draw 2 more. So 2 more and 2 more there. So you can see that there each nitrogen thinks it's got 8, 2, 6, 8, and that one there. So that would be the correct structure for nitrogen. Okay, let's do one more before we finish that. Let's try carbon dioxide. So a pretty important molecule. CO2. So carbon is in group 4. Oxygen is in group 6. So, right, remember, carbon likes to form 4 bonds, oxygen likes to form 2. So if we draw our carbon there, a bit smaller, carbon and oxygen, you can see that that's not going to be satisfactory. Each oxygen is only forming 1 bond. They like forming 2, no good. Carbon is only forming 2 bonds. It likes to form 4. So fairly obvious solution to that is to make both of those double bonds. Now each oxygen is forming 2 and each carbon is forming 2 there, 2 there, so that's 4. So that must be the bonding in carbon dioxide. So if we draw what this looks like. We've got carbon there, and oxygen. That's step 1, the overlaps. Step 2, put the electrons in. Okay, so let's do the carbons, electrons as crosses, and we do the oxygens as dots. Okay, so they're double bonds, so you need not just a pair of electrons, but 2 pairs. So we want dot, cross, and in this one we want dot, cross, dot, cross. Step 4, does any other electrons to put outside of the bonds? Well, carbon has got 1, 2, 3, 4 electrons, and so no, there's no other electrons outside the bond for carbon. Oxygen has got 6, and we've only drawn 2 for each oxygen, so we need to draw 4 more. 1, 2, 3, 4. We can see finally check each atom is a full outer shell. Well, the carbon thinks it's got 8, that's no problem, and each oxygen thinks it's got 8 as well, so that's all worked out. So that's the correct structure for carbon dioxide. Okay, before we finish, let's just think about this hydrogen cyanide. Okay, HCN is the formula. So how could that work out? Well, let's put the carbon in the middle. Well, let's put the nitrogen there. Let's see what happens. Okay, so draw a bond to carbon and a bond to hydrogen. Right, the hydrogen would be happy there because that only likes forming 1 bond. The nitrogen wouldn't because that likes forming 3. Okay, it's only forming 2, so I can make that a double. The nitrogen would be happy, the hydrogen would be happy, but the carbon wouldn't like this because the carbon is only forming 2 bonds. Carbon likes form 4, so that's not right. So let's put the carbon in the middle then. Put a hydrogen there, nitrogen there. Okay, hydrogen is happy, forming 1 bond. This nitrogen would not be happy, it likes to form 3, so that's got to be a triple bond. Now let's see, would the carbon like that arrangement? The carbon's forming 3 with the nitrogen and 1 with the hydrogen, so it's forming 4 bonds. So yeah, that is the correct structure for hydrogen cyanide. And you can draw the dot cross diagram for that if you like. And I might as well do it, okay, while we're here. And if you know what it is, just fast forward to the end. So there's our carbon, there's nitrogen, and there's hydrogen. I'm going to have to use a third symbol here. So the hydrogen electrons I'll do as little triangles. The carbon electrons as dots, and I'll do the nitrogens as crosses. Right, hydrogen, carbon, nitrogen. So here you've got, in this overlap, draw the electrons in the overlaps, a single bond, so we have a dot from the carbon and a triangle from the hydrogen. This one is a triple bond, so we want that's a triple bond. Okay, number 4, are there any electrons to think of from outside of the bonds? Well, the hydrogen, no, that's just 1 electron, that's fine. The carbon, well, we've accounted for all 4 carbon electrons, 1, 2, 3, 4, so no electrons outside of the bonds for carbon. Nitrogen, we've only drawn 3 bonds, 3 electrons, it's in group 5, so we need to draw 2 more, so draw that. Finally, step 5, we need to check that each one thinks it's got a full outer shell, and you can see that they would do. 2 for the carbon there, and 6 there makes 8, and the nitrogen 6 there and 2 there make 8 full outer shell, and the hydrogen's got a full outer shell as well. Okay,